The broadcast is now starting. All attendees are in listen-only mode.
This webinar will begin shortly. Hi everyone and welcome back. This is the second webinar in our webinar series and thank you for being with us today. Today we are joined by Jason Arbon. AI will soon test everything. There is 10% still off our tickets. That offer is only available to the end of this month, so the 28th of September. So please, if you do want to attend the conference, this is the only time that you'll be given a discount. So head over there and get your tickets for The Hague. We also have an offer at the moment. It's 5 tickets for the price of 4. So if there's a group, this is a great group offer. So please do avail of that. If you want to ask Jason a question, please put your questions in the chat box on the right-hand side of the screen. I will allocate time at the very end of this webinar to ask Jason those questions. So at any time during this webinar, just stick them in the chat box there. So without further ado, I will hand over to Jason, and I thank him for being here at this very early hour today. Hi, Jason.
Excellent. Thank you.
No problem. Good luck.
All right, I need it. It's better to do a webinar because people can't throw stuff. But all right, so yeah, I just want to get everybody together and talk about how AI will soon test everything. People are often skeptical, especially testers, thinking that, well, there's a lot of things that computers will never be able to do, or at least will be like 10 or 20 or 50 years out. And so I just want to share some of the progress on multiple fronts in terms of how AI is starting to actually test software, whether we like it or not. So don't believe me. There's this guy named Andrew Inge. He's pretty awesome. He's super smart. He, was a professor at Stanford teaching machine learning. He's also, led the Google Brain project and a bunch of other stuff. But he says that anything that a normal person can do in less than a second, machines can do now, right? You can train an AI to do that, which is kind of interesting, a little humbling, but also not too crazy, right? That kind of makes sense. The machines can tell if it's a cat or a dog in a second, just like a human can. But what's interesting is that most test decisions, if you think about it, actually take less than a second of your brain. When you look at an error dialog, that's a problem, right? In less than a second. When you're doing exploratory testing and you're thinking of an interesting, test input to try to break the machine, you can come up with some of those test cases in less than a second. So, well, what does that mean? What that means is that it's very likely that AI is already here. In fact, I can assert that it is. We'll see some real-world examples and data of AI applied to software testing. This is one of my little favorite animated GIFs on the planet. This is just a picture of one of the first versions of the AI stuff I was hacking on. And what this is the first example of that I know of AI running against an application it's never seen before, and just like a person identifying that the app is asking for location access, and it decides to allow it because that's an interesting thing to do. And it, are you sure? And it says yeah, and it keeps going and testing the application. This is the first time of AI is really, never seen it before, doesn't have access to the design, and nothing was hard coded. No human was involved to start driving and testing that application. So just like to start with code and like running code, because this stuff is real. It's not a bunch of just slide decks with project, I don't know what the word is, but people talking about the future and what's going to happen in the future, and somehow they'll analyze the logs and figure stuff out for us. The AI is actually running already today. So a lot of times when we get technological revolutions, people talk about it, being better, faster, and cheaper, and all these things are actually true. So far, I've seen with the AI and ML approaches, AI and machine learning approaches to testing. But we'll skip that stuff. That's kind of for the business end of things. Let's talk about the technical aspects of what's really going on with AI and testing. So one of the first things that probably is shocking to most testers is, and they probably won't realize it, and they'll still won't believe it after I show them some data here, but AIs are going to be smarter. In fact, there already are AIs smarter than human testers today at particular tasks, right? They're not as good looking as you. They can't drive a car very well yet, but they can do a lot of testing tasks better than most human testers. So if you don't believe it, consider just a couple facts here, right? One is, these are a lot of shopping carts. So these are shopping carts used in applications, in the UI of applications. So if you're shopping, in one of, the 10,000, 100,000 retail apps on the web or on mobile, these are the icons that they use to indicate the shopping cart. Some of these are even from other places in the world. But if you think about it, if you look at these shopping carts for a second, as a tester, you probably haven't seen most of these before. Like, you've just not ever seen them because you haven't even had that much time in your life to explore and see all these kind of shopping carts. Moreover, some of them may look almost strange to you, and you can look at it and within a second go, oh, I see why that is a shopping cart. For instance, there's like a baby carriage in here. Well, why is that? Because there's a shopping app that, you're shopping for baby clothes, right? But it's a cute little icon that looks kind of like a shopping cart, and combined with a baby carriage. So just like you in 1 second can assert that, yeah, these all make sure they all make sense. These all kind of look like shopping carts. We can train AI to do the same thing. And here's another example with sharing buttons. Again, right? You've seen there's a lot more sharing buttons out there than you've seen, but they all kind of look the same. So what happens? How do we teach these bots, right? How do we teach them how to recognize things like we do as human beings? It's pretty simple these days. You really just get a lot of examples. You've heard about this. You have big data and all stuff. You don't really need giant data. You don't need petabytes of data, but you do need like lots of examples. Tens of thousands, hundreds of thousands of examples of these different things. So looking here, like sharing, refresh, mute buttons, play buttons. So we spend a lot of time and money, venture capital money, collecting all of these, labeling all these things. We have like humans around the world labeling all these things, saying, yeah, that was a shopping cart. Oh, that's a play button, right? And after we gather a bunch of that labeled, human curated, labeled data, we send it out to the crowd, right? And they confirm and they double check that all the labeling is correct. And really this is, we'll get like between 20 and 100 different people labeling these things and saying, yeah, that is a shopping cart, again and again and again and again. So what's interesting is that, so how does this lead into why the AI can be smarter than a human? The machines have seen more shopping carts than you'll ever see in your life. And they know it's a shopping cart because it's been trained on data from 20, 100, 1,000 different people on the net that all have also seen different aspects of shopping carts around the world. So what the AI ends up being is trained on the collective knowledge of all of those people, and they have also seen many, many more things than you have. So if you think about it, just like slightly, a little bit, without a little bit of human ego involved, it's pretty probable that a machine can actually recognize a shopping cart better than you can, and a share button and so on in applications. And to give you an example of how this works, most software testers, I read an article this morning, while I was waiting for the webinar, somebody's super proud to have an article about how to scale testing from one app to 2 apps, right? And it's this human-involved planned activity with redesign and abstracting objects in your application and all this kind of stuff. But already what's going on in the world today is these are just some small subset of the screenshots that our AI has, of the apps our AI has already tested, right? It's tested more than tens of thousands of applications already. And without permission of the app owners, because we can download these from the App Store, and on the web we can connect to the URLs without permission from anybody, and our AI can already go about testing and exploring these applications. And that exploration is intelligent because it knows what all the little pieces are, and it knows what the typical patterns, we'll get to that in a second, of normal and well-behaved apps, how normal and well-behaved apps behave. And again, why would the machines be smarter than the average tester? You've never tested this many apps, let alone even use those apps, right? That many apps yourself. So the AI is seeing a lot more than you ever have and you ever will, just by the nature that they're paralyzed in their machines and they don't need to eat, drink, sleep. They just run. So let's talk about a couple areas where, one is now we've got these bots that can recognize what's in an application, right? And in many cases better than the confusion matrix that a human has in terms of whether it's a shopping cart or not. So now how do we get them to do UI regression testing? And the reason UI regression testing is super important is that, well, for instance, the World Quality Report came out today or recently, I just saw that, and the #1 thing everybody's chasing is user satisfaction with the application, right? More above and beyond performance, stability, even functional correctness sometimes. They want the user to be happy, and it's focused on the user, the end user. It doesn't matter how complex your back end is, or if some internal API is really slow, but doesn't impact the user, it doesn't actually matter as much. What really matters is where software connects to humans. And this has also been traditionally the most difficult place for test automation. If you talk to most, Appium or Selenium or other kind of test framework engineers working on UI automation, their lives are painful, right? Those frameworks are super useful. It's a super painful thing because the UI changes and it breaks all your code, right? And it's just very slow to write UI regression test cases. It's easy to write unit tests and most integration tests. That's why we have a lot of them, but UI regression has always been the most difficult thing. So you'd say, well, AI couldn't do that. Humans can barely do that. How the heck would an AI or a machine do that? Well, a quick example of how this works, at least one example that I've been working on is called reinforcement learning. Inverse reinforcement learning is another topic, but it's called reinforcement learning. And what it is, it's just like when you were a kid and you're playing video games, right? There's no really instruction manual for most of these things, but you figured out how to play Mario by walking around, and then you run into a mushroom and you die, right? And you go, that was not good. It was associated with death, and it was associated with no points collected. And so we learn, just as humans, to play these video games by getting rewarded. When we do something good, we collect coins, and we don't die, we get points. And when we save the princess at the end and the flag, we get more and more points. So just like humans, the Google Brain DeepMind team has been focused on creating AI using reinforcement learning that can play video games, learn to play video games, right? And you don't teach the computer heuristics. Like in testing, we'll say, hey, click this button and then click this button immediately after. There's no hard coding of these bots that play games. They just play lots and lots of iterations of the game, just like a human does, and learns to play the game based on rewards. So I figured, well, walking through a video game, it's pretty amazing. That's pretty fun. It's a cool demo, but it might be more practical and might be very similar to walking through like how a tester walks through an application, executing a test case, right? Either playing around and exploring, or also just they have a directed mission, like I want to go get that coin, right? Or I want to jump over that mushroom. So if we kind of do this mental map from video games to test execution, we realize that much of the techniques that are being developed and deployed, kind of the cutting edge of machine learning and AI today, are very directly applicable to software testing. So we built this basically Rube Goldberg thing that works. It's kind of it's a whole session on its own. But essentially, the AI bots will walk around the application intelligently like a human, build a graph of that application, and then we feed it what's called an AIT test case, which is a high-level kind of Gherkin-style test description. It just says, hey, go to this part of the app and then verify something in there, right? Or add 2 things to the shopping cart and verify there are 2 things in the shopping cart. It's very simple instructions. Same things you could even just verbally communicate to a human, and the human can figure out how to do it. The bots can do the same thing. So we let them play and run around this application, sometimes up to 10,000 times, trying to figure out how to execute not only every test case, but all the different ways and ideal ways to execute every step in a test case. So and again, in some way, these machines will have executed that test case thousands of times more than a human could have ever done it. And again, on even thousands of times more apps than any human would have ever done it. So it's just this virtuous cycle where we train these things, and they can look at an application, even an application to be clear that they've never seen before, and execute the same test case, just like a person can. If I gave you a new shopping app, and I said, go find the shopping cart, or add 2 things to the shopping cart and verify 2 things are in the shopping cart afterwards, and I give you an app you've never seen before, even maybe in a foreign language, you'd probably be able to do it. So very similarly, again, back to those, most test for decisions are less than a second, and they're very relatively simple tasks most of the time because end users are supposed to be able to accomplish them. We can teach machines to do the same thing. If you're a tester or you're a test automation engineer and you're like, yeah, but can it do this? Or can I have super direct control or talk to the database in the middle of a step? It's really just relax your mind a bit and realize that things are changing, right? And realize there's no code involved. So, like, the infrastructure is very complex, right? It's not just a simple, little API calls. There's like all this training and this brain behind it. But fundamentally, there's no code. We're able to start testing applications with no code at all, not even generated code. Like, some people are out there, it's a good effort, but to generate, record and playback scenarios, and kind of use AI to fix up the selectors when they break, or people are also doing things where they generate code, and they claim kind of use AI a little bit to generate the code. But the reality is that, again, you're generating code and it's brittle and it breaks. And what we're doing here is actually combining reinforcement learning and classic neural networks to identify parts of the application. So it's wholly and completely AI, and that makes it super robust, because if the flow of the app changes, the AI can note that, hey, it changed, but it can keep walking, and just like a human, and continue to execute that test case. There's no code that needs to get updated. So here's a quick just a visualization of what this empowers. So, some of the folks are working on things, they're intelligent bots that crawl through an application kind of like a human would, and we say, okay, that's decent exploratory testing, and maybe it'll get some, quote, coverage in terms of exercising the application, and maybe look for crashes. But when you have the AI be able to crawl an application, cut it up into little pieces, like, these are different top-level categories for bird stuff, cat stuff, small pets, fish, dog. This is like an online pet shopping app. But it can cut all those little pieces up and present them to you, and you can just drag and drop to compose test cases, right? You can say, hey, in this case, click on the small pet, category, right? Go into there and then find something and add it to the cart. But you can just drag and drop. So you can create custom test cases. And then the amazing and powerful thing here is then the AI actually figures out how to construct those test cases and how to execute them at runtime. There's just no code involved. And again, the AI has never seen any of these apps before. So a powerful thing about this, I think this is one of the key aspects of how AI is going to impact the world of software testing and generate more test coverage than humans ever have in very short order, is through the issue of reuse, right? Because the AI is not hard-coded to any specific applications implementation, and because the AI is not, because the test case logic is not tied to that, these test cases can run on more than one app. And so we can finally have basically treat engineering like a discipline, you know, like where developers or even civil engineers get to reuse designs, reuse infrastructure en masse. Testing is usually done from scratch every time. When a team wakes up, we've got a new application, let's start testing it. They start with almost usually an empty, you know, Python or Java file and start coding, right? In this new world of reuse, there will already have been test cases written that are applicable to your application. In fact, you can run them right away. It's almost an extreme form of TDD, or, you know, test-driven development, where the test cases actually pre-exist before your application, and you can run them against your app as soon as on your very first build. So as part of that effort, I won't talk about it a whole lot, but we're working on taking a lot of this machine learning and logic and stuff in terms of reuse too, is not lock it up into our you know, my current company solution, but we're gonna open source this stuff. So we're gonna open source, working right now to open source the work that allows the machine to identify all those shopping carts and those share buttons and stuff just by name, right? So traditionally you say, I wanna find an element in the application by some CSS selector or XPath or some magic ID. You have to go find out what that is, and if that changes a little bit, it all breaks and so on. But the simplest probably way to do this stuff is if you're programming, if you still want to use Selenium and Appium, that you can. I only laugh because there's a lot of things, you know, AI still can't do, right? But so how do we bring AI into all these test automation engineers tool sets? Well, we just add an API and we say, you know, hey, just find an element by a label called search, search box, right? And it will go and find the search box and give you a pointer back to it so you can click it or do whatever you want with a button. So again, this is just an attempt to share, but even reuse, not just reuse test logic within a framework across applications, but reuse the work and effort that we've done to categorize. And there's no other testings in the world should have to go through the money or cost or pain of, you know, labeling 10,000 shopping carts, right? That was brutal and expensive and painful. So we want to share that with the world and integrate it with as many frameworks as possible. So this is an example of this stuff running in the real world. So say we just think of, okay, we're doing testing some web search and web search application. Forget which one it is, and say you want to search for the word gradient, right? Well, if you want to do that, you can describe that test case like I just described it with human language. You can describe it in this kind of AIT format, but you can say in very high levels, you know, like just get to the search screen, right? Click the, you know, enter the text gradient into a search text box that you find, and then click the search button, right? And then verify that one of the things that shows up has the word gradient in it. You can write that test case without ever seeing the application in your mind. The problem with a lot of, not just a problem, I don't forget about the problems, but with the way AI does it is, again, it's that dynamic, right? So we can pass it any number of web search apps. In this case, we have on the right-hand side, we have the pictures of the flows. So we basically wrote this test case in isolation, just wrote it down. That's a basic hello world test case for a search engine. And we gave it the Google mobile app, right? We gave it the DuckDuckGo, we gave it Bing, we gave it Yahoo, and it run, you know, on iOS apps, Android apps. And guess what the AI does? It figures out like a human, making quick 1-second judgments on each page, what to do next. And it was able to execute these searches across all of those applications, right? So if you notice in the middle row, it's actually the same test case, not only is executing across, you know, applications, it's also across platform. There's the Google website in the middle of it. You just pass it the URL instead of the APK or, you know, or iOS app, and it will execute the test case. It even executes the test case on Yahoo, sorry, on YouTube, which is, it has a search box, and you say search for gradient, it can search for gradient. Forget that even if we didn't intend for it to be used on a video app. So this is kind of an extreme kind of case of reuse, and it should be exciting and interesting to people that we can build test cases that have much reuse and are reusable across platforms and applications. And a fun thing here too is that you realize that if we share test artifacts, we're not used to sharing much in testing world because our stuff's not reusable. But if an engineer at Google wrote this test case, right, for their web search engine, they could share the exact same text to the YouTube team and to the Bing team and to the Yahoo team and to DuckDuckGo, and then they all can execute that test case. We can reuse test cases across companies. So that's something we'll see coming soon. But you can imagine here now with AI-powered test cases, we're getting a level of reuse and scale that we've kind of never dreamed of or thought of. People don't think about automating a competitive app, let alone even sharing with their competitors a test case. So what does this mean? How does this really work? An example here is there's a bunch of mobile. There's a bunch of mobile apps here, right? What do these do? They just check the score of sports games on the planet, right? You can get player stats. You can watch live games. You can get team stats. What's going on at a particular stadium? That kind of information, right? Just sports information. But you can imagine we can write a set of test cases now, if you've seen that web search one, that tests most of that common, similar, basic functionality, right? Does it have our sports scores? Does the sports scores page still show up, right? Does the fantasy sports league link show up in all of these? When I do a search for a player, if I search for LeBron James, does it take me to a player profile with LeBron James on it, right? You can write these test cases now and rerun them across a whole category of applications. It's just a little nerdy way. This is another way to write these tests, right? It's very simple, but you can imagine there's 20 simple test cases and that are applicable to all these applications, and they're parameterizable. That's why the sports player is and sports team and sports venue they're basically like parameterized values. So you can search for all sorts of different players or teams or venues. But we've just wrote 20 test cases that are reusable across 15 apps that I don't work for, I've never seen. I may not even tell them I wrote the test cases or executed them. And these are reusable across all those apps and across platforms. So as long as the apps have roughly the same design and roughly the same kind of features in it, the test cases are reusable. It's pretty exciting. So testers will go like, what about exploratory testing, right? By the way, when I talk about AI, they go like, yeah, but they'll never do this, or yeah, but they'll never do that, or well, so a lot of people say like, well, you can't do exploratory testing, right? Because that requires human intuition and understanding of how apps are supposed to behave and how they're not supposed to behave, and it's very dynamic, right? That's the sacred special zone that humans can hide in. Maybe let the AI do all the hard regression and boring regression work. But exploratory testing, that's the human domain. That's where we're special, and we're going to be employed for the next 20 years doing this stuff. The reality is, let me see if I play this little video here. So the reality is, here is exploratory testing running on Amazon's app, right? So what this is doing, it's not just clicking through the application and doing intelligent things. What it's really doing is it's waking up, looking at the application, seeing what things are in it. Of course, there's one little, I wouldn't say a cheat, but there's one little thing here. You can pass a username, password, and the bots know how to use it automatically. Just pass it, username, password, and it can log into anything. And yeah, don't use that password, please. I just trust the planet more than I should. It's one of our bot accounts. But what happens is that it looks at the page, and then it looks at this repository of 3,000 test cases that we've already defined. Right. So if you see a product item, add it to the cart. Right. If you see a search box, perfect timing, I think, then do a search, right, and execute the search and verify that something related to the search that you typed in shows up on the search results. So this is dynamically, and this is, by the way, real-time speed. It's pretty fast. People were AI, all this compute time and all this stuff. No, you can run it real time. But it's executing tons and tons of test cases to verify features and functionality as it walks through the application. There's more to come on that topic, but suffice it to say that these bots can do a fair amount of exploratory testing. So then testers will say, well, what about subjective things, right? This is the last bastion of humanity, which is, well, how do I tell if it's trustworthy? Or in fact, this was actually there was a post from Philip Liu from PNSQC this morning. There's a paper, somebody submitted a paper on, it's important to worry about how much your app's behavior and design impacts trustworthiness, right? How well do users trust your application with their information, with authority, with in general, like how much do they trust your app? Well, that seems to be and that paper talks about getting a bunch of user panels and opinions and all these thoughts and stuff. But like, could a machine ever do that? Could a machine ever look at an app and say, or even a screen of an application, say, like, yeah, on a subjective scale of like 0 to 10, that's like a 7 out of 10 in terms of trustworthiness, right? Like, people just don't believe this is possible with machines. But I'll share this. I've never shared this before. We did an experiment where we took a bunch of login screens, so from applications. So I don't remember what it was, how many it was. It was 1,000 or 2,000 or something login screens. And we just took the screenshots for these login screens. And it's easy for us to get login screens because they're machines label it login screen. So we get all the login screens and we just passed it to humans with this little tiny app on the left. And yeah, we've got our text off the edge because it's our internal kind of crappy app. But they could say they strongly agree, disagree, or whatever, whether they would trust that app, right? Just by looking at the screenshot. And we did this for, we had, overvotes, we had, overlapping votes from I want to say it was at least several hundred people. Sorry, exact number doesn't matter. It's a lot of people, and they all we took all their votes into account. And then what we did was we got all those votes, and we said, okay, now, this particular application has a 4 out of 10 on average in terms of trustworthiness, right? And then we do that for all of these different screens. This is just intimidating bar charts and scatter plots, doesn't matter. But what happened is that the machine was now able to take, we now crawled it again, sent those same trained AI bots on that data we got from the humans in the crowd, just like we did with finding elements and pages. We trained it on the data from the humans about trustworthiness. And guess what it does? It went through the 5,000 other apps that we have never seen before, and the AI had never seen before. Looked at the web, looked at the page, looked at the login page, and gave it a trustworthiness score. You go like, okay, well, how do we know what's right? And like, if you ask me as a human tester, and some people are confused, I'm actually a human. I'm not just a LinkedIn or Twitter posting bot. But what is interesting and fascinating is that if you ask me what trustworthiness means or how I would write that heuristic to determine if an arbitrary page was trustworthy or not, I would have a difficult time. I'd have to sit there and think about it, right? Think about it, maybe even start talking to other people, like the study had, like talk to a large panel of human beings and see what their feelings are, what they think might be trustworthy or not trustworthy in applications. And I'd have a tough time doing it, and I would have low confidence that I was getting it right. But the funny thing is we can bypass the tester in this sense and just get end user feedback and then train the bot to emulate that end user feedback and evaluation of the application. Skip the tester in the middle and skip that tester's intuition, skip that tester's brainstorming, and they may or may not get it correct. So just learn from the actual data from the end user. And what we saw was basically the bots did better, than any single human being did at getting the correct average trustworthiness score. So again, an example where bots are better than humans, not only just faster, better, or cheaper, but they were more correct than the average human being. And importantly, so we step back and go like, well, how did they figure that out? So we kind of cracked open the brain, looked inside the network, and said, what is it really looking at in the page? What does it care about determining after learning on thousands of different screens? How does it figure out that these are trustworthy or not trustworthy? And what we found out was that there are a few signals that it particularly paid attention to. One was if the application had characters from another language. So if it was in the English ENUS App Store, but it had Chinese characters. So if it was in the German App Store and it had French characters, it would be weighted as not as trustworthy. Probably because the people in that App Store in that area of the world can't read what it's saying. It might be saying, I'm stealing your password, right? In a foreign language. So you don't trust it. You're a little concerned about what it's doing. Also, the more we discovered that the nets looked and said, the more complex the login screen was, the least trustworthy it was. I guess the assumption might be that if they have to tell you a lot of things before you log in, it's probably a little bit dangerous. Like they're warning you about a bunch of stuff, or it's just more things you don't understand or have to process, right? And then thirdly, in terms of like a positive signal and trustworthiness, if the page had a very well-known brand, right? So Disney, Nike, Google, and that branding was very prominent on the page, then people trusted it more. That makes sense, right? That actually makes sense. So what's interesting here is the bots have actually figured out these things that almost make sense to a human, but without a human involved. And these are qualitative. Oh, that's funny. I've got the internal use thing on it still. That's funny. Makes it feel more like an expose. But we've got I overshare. But these machines have learned to do this better than humans, and humans have now learned from the machines how to make that judgment. So if I'm talking about to a new app company tomorrow, and they have a draft or design for their new login page, I can now take the heuristics I learned from the bot and say, hey, you probably want to you have a good brand, strong brand. Probably put the logo prominent on the page, right? Hey, you got a bunch of text over here. Take some of it out, right? You're adding confusion and ambiguity, and definitely don't put the wrong language in there for the domain that the app is deployed to. So this is pretty this is where I learned from the machine, which is pretty exciting. And again, this is qualitative data, what people think is the last bastion of testing. So an important aspect of AI is that it gets better with scale, right? So this, and just more data. So this is the part that should scare people. This is where the exponentials come in, right? When we write test cases today, we write one after the other. We execute them one after the other. It's a linear thing, and it's limited mostly on human capacity to write test cases and execute them. But there's a magic thing about AI, and the more data it has, the smarter it is. So one thing you can do with this, with more data and all this stuff, is we've automated like lots and lots of apps. And if you look at it, because the AI knows, hey, that's an article page, right? So these are a bunch of news applications. So it's looked at all these different apps and said, okay, that's the login screen, that's the home screen. Oh, whoops, there's an article. So now we can compare article page load times across all these applications. So if you worked at NPR, the second one from the top, your team might feel pretty good that you've got 1.3 second page load time for your articles. You may feel pretty comfortable with that, but you'd feel less comfortable if you knew that CNN's app is only like 600 milliseconds, and the BBC, which may even host its servers may not even have CDN in the US. It may be coming all the way from the homeland. Is even faster at 585 milliseconds. So that may be motivating for you to understand your performance in context, and this is kind of gives you a competitive view. So a lot of this data lets the AI also benchmark applications. So in the NPR news, people or somebody builds a news app, and the AI looks at it, it can tell them in real time, hey, you're in the bottom 10% of article page load timing, right? Because it has a lot of data. So the more apps it's seen, the better context, the better benchmarking the system can provide. And again, more motivating to the app teams to fix issues. Or if you're the BBC folks, you go, maybe we've over-optimized our article load time, right? So what happens is we've got this virtual, I stole this image and I forgot where it's from, somewhere on the internet to be precise. But the idea is you've got this loop, right, where you get a baby version of the thing, you get a little bit of data to train the predictions, the AI, and then it gets to customers and crawling real-world apps and getting more data, and that goes back to the feeds to make better predictions, better product, better algos. And it's just this kind of vicious loop. And I say vicious because humans don't get that fast, that smarter, right? I mean, that smarter, that fast, or more better. They lose this game because they don't have the ability to iterate purely on data, and they can only test so many apps at a time, where the AI in parallel can literally theoretically test every app at the same time. So when you think like AI is just getting started, it's a baby movement, you'll realize that you're seeing the beginning of an exponential curve, and this is just going to take off like a rocket because we have a feedback loop in terms of the amount of coverage and the quality of the coverage and the data that these systems will produce. So ultimately, I want to talk about this for a quick second at test.ai. What we're really doing is we're doing this. We're taking all these devices, all these apps, all these human input, and we're merging it all into this nasty-looking little pink brain, apparently. But we're taking all this collective intelligence from humans and all this experiential data from actually testing and executing applications in the real world and in production, and we're building a brain that's probably smarter than most every tester. I know I already feel the brain is smarter in many areas than I am, and I'm an old man and I've been testing for a long time. But that's really what we're building. And the reason I want to bring this up is that people, we get lots of inbound requests to use Test AI. This isn't an ad, by the way. This is just me sharing while I have a chance. That people want to use it today, but people don't realize our mission is to test all the world's app. It's not specifically your app today, but like all of them. So that's what we've been raising money, and we've been getting a lot of machine learning engineers and a lot of experienced test automation engineers together. We're focused on automating all of the apps. So we're automating your app today without your permission. We might know more about your app than you do today. And we hope not just in open sourcing some of our methods and methodologies so you can use them in your test labs and environments, but we want to share and I think I especially have to sell, but this data in mass, right? About all this benchmarking data and all these automatically generated and reused test cases. So we probably already have a BVT or smoke set of test cases for your application running in our labs, and I hope to share that pretty soon with the world. So yeah, AI coverage. So again, this is what I was talking about earlier is, exponential curves. Humans do not process exponential curves. We get linear things. We get things that happen that, that double or triple or something, but not continually triple. So we're going to see, AI's impact will be quiet, and then it will come out of nowhere, and we'll be like, what happened? What happened to my career? What happened to all these little test suites that I've mainly curated for years? And we'll probably wake up and see, testers will probably wake up and see their dev managers or product managers, we're doing actually like looking to the web first for the quality of their application, because there'll be bots on the web that are testing the app more thoroughly than the internal test teams. So that'll happen at some point. So then last note on kind of testing systems, there's a really fun geeky thing happening in testing. And no testers are really paying attention to it. But how do you test AI systems, right? This is a little bit difficult for a webinar, but this is how we measure our own internal, basically precision versus recall thresholds for identifying particular elements in applications. This is how confident we are that we've measured those things correctly. We're labeled them correctly. We've done some cool work to optimize that. Every little gray line is basically, this is the trade-off between accuracy and confidence, and has a function of the threshold. So when the AI says, I'm 80% sure this is a button, it's pretty sure it's a button. But you may also say, but for a sharing button, you may need to say, only tell me it's a sharing button if you're 90% sure, because sharing buttons can look similar to arrows, right? So there's some confusion in between humans and the machines that were trained on the human data as to what's a sharing icon versus an arrow, for example. So we've done a lot of math, and this is how you test AI systems. It's not writing a bunch of test cases. It's doing a lot of data and analytics and iteration. This is kind of fun, but we don't need to go into that. So this is interesting too. So when you apply machine learning, it's not just like you make this magic brain and it just works on everything. You've got to be very careful about which corpus. If you train it, they call it narrow AI today, right? For a reason, and that is that these AIs get trained to a very specific job. Like there's one AI that knows that's a button. There's another little AI brain that knows whether that's a search box or not, right? We have lots of these little tiny brains. They're very specialized. If you take a very generic, image recognition system like the one that Google made, they have a few engineers, a few dollars, a few machines, and they scour the internet, and they look at all these images. And the funny thing is, if you send them a picture of my profile, we just accidentally found this the other day. It looks at my face and it says it's a toilet seat, and sadly I'm spinning in the middle of the thing. But Test AI's AI at the same time just called it a profile icon because it's seen a lot of domain-specific things. It's seen a lot of little parts of applications that it knows that's probably a profile. It's a picture, it's rounded, it's kind of the right size. It's probably a profile icon, right? So even, again, don't be intimidated by companies that have a lot more money, a lot more data, a lot more engineers, a lot more money. If you build very specific corpuses tuned to a very specific job, it can be specific to your application, right? You can be far better, smarter AI than the big folks can. So don't be intimidated by that. Don't think you need, petabytes of data or 50 engineers. Just focus on a more narrow, more specific, more useful task. So this is where things get crazy. So I don't know if anybody knows about the Singularity, but that's basically when machines take over the planet. But if you look at what's happened just in the last few months, literally the last 6 months or so at Google, there's this thing called AutoML. What that is auto machine learning. So what are happening now, it's literally happening in front of our eyes. Like if you said this like 10 years ago, people would be like, except for a few people in the labs, right? But if you told a normal human that machines would start teaching other machines how to think, that's craziness, right? That's not even like worthy of a sci-fi movie because it's ridiculous. But we're seeing this already where there's parent and child neural networks, and the parent figures out how to configure and how to, basically, to be simple, to configure the child neural network to do the task that you have at hand. So what this means is that a tester without any machine learning experience, any any math, kind of deep math or statistics background, can start using machines. You give the problem, you give your answers to the machine, and it just goes and figures out and creates some machine learning, either neural nets or decision trees or something that will accomplish your task without you doing much of anything other than just here's the examples, right? And this has happened. I wish we had this a few years ago when I spent all this money to handcraft all this stuff. Even more crazy, like literally, I think it was just last month. There's a specific version of the auto machine learning that does vision. So this one, you literally just upload any image you want, and you can call it whatever you want, and it will come back and classify it for you. It'll just train your model for you, train your AI for you. So for people who are looking, I get a question of people like, how do I get into AI and machine learning? And most of the answers are, go get a PhD in computer science, or take like 1,000 hours of Coursera, or watch YouTube videos on this tech. Literally, you can probably skip ahead and start playing with cloud ML, cloud auto ML, and kind of jump ahead and start experimenting and playing today. And so if you go back here, realize part of this training process is most of the training is actually testing to see how well the bot is doing on the problem at hand. So really what's buried in here is the most sophisticated testing, generic testing infrastructure on the planet. They all think they're machine learning engineers, but they're really just testers building very elaborate and sophisticated test infrastructure to auto-configure and test all of arbitrary networks. So yeah, this basically leads to the possibility of a singularity, right? Like we're already having signs that not only can AI speed up testing and make it smarter and scale and get some more reuse, but we're starting to see things where the machines actually are creating other versions of machines and optimizing themselves, right? Which is a very simple problem statement. I can imagine in short order, we'll have machines, I love this is recorded actually, we'll probably have new machines that look at the world and figure out patterns that are interesting or monetizable, and then just spin up AutoML to create solutions and applications. So there may be no human in the loop at some point in terms of building or optimizing applications. So people want more information about AI and software testing. I co-created this with Tariq King, this little association to focus on this topic of AI and software testing. And just whenever, there's not a lot out there, but whenever I run into stuff that's useful and interesting, I'll post it and pump it out there. We also have an occasional online conference or so. They're kind of irregularly scheduled, but we try to get people together, even at other conferences. I'm not going to be at Eurostar this year, but if I was, we'd probably have like a meetup and get together in a bar or something like that and just geek out on the topic. So if you want to be aware of what's going on and connect to other people that have shared this interest, just sign up on aitesting.org. Just basically a mailing list. So that's it. I hope you realize that AI is actually here. It's doing a lot of things. It's doing things you never dreamed of, and you should be both a little excited and also a little bit reviewing what your skill set is and how you fit into this new world order, because it's starting slowly, but it will explode before you know it, and dramatically change your career and software quality in general. If you want to get a hold of me, I'm pretty lonely and geeky guy. I'm just Jason at Test AI, and I spend a fair amount of time on LinkedIn and sharing a lot of details about how to build such systems, and like a lot more details and technical details on LinkedIn. So that's it. If anybody wants to have Q&A or have, if they have negative things to say or challenging things to say, that'll be good to keep me awake.
Thank you, Jason. Yeah, certainly there's a lot of questions that have poured in with that webinar. So thank you so much. It was really interesting. And like you said, questions on excitement and terror at the same time. So guys, there's still time to ask Jason those questions. The chat box is there on your right hand screen, so please use it. You can join us again for the next 3 days. We've 3 webinars left in this series, so if you haven't already, please do head over there and register. So Jason, I'm just going to pop up these questions here. Just 1 second so I have them clear in my vision. Okay, so there's a lot here, so I'm just going to try and do my best to kind of avoid duplicates and as such. And Jason, as you mentioned, you have your slide up there about your contact information. So if I didn't get to you guys, Jason, are you happy for them to reach out to you in some sort of way?
Totally, yeah, I'm lonely.
Okay, okay, great. Okay, so let's start. How would the AI cope if faced with the CAPTCHA when determining the trustworthiness source of an app? Would the test be abandoned, or would any usable data be yielded from the execution run?
First of all, the first response is that which we don't use today, but running into a CAPTCHA, how is that interpreted by a human in terms of trustworthiness? Whether it's good or bad, again, I would go back and almost answer that. I wouldn't answer the question myself. I would actually just do another experiment where I would send out a bunch of pictures of or videos of the app, spawning a CAPTCHA, and with it either accepting the CAPTCHA or not, and then just get a panel of 100 to 1,000 people to just tell me what they think, what their trustworthiness is, and then train a neural network to recognize that. So I wouldn't even, at this point, I wouldn't trust my own intuition, especially as a single human or a single individual. I would turn to the crowd to determine that, and actually end users if possible, and then just train a net to make that determination without me, which is crazy, right?
Yeah.
Like I'm losing my value as a test expert, and just deferring to data and then training networks to make the decisions for me. And the beautiful thing about training the network to make that decision for me is, if somebody particular asks me about a particular app, I could give them the information. But once I've trained a network to do this, we can run it on every CAPTCHA on any app on the planet, or an app that's built tomorrow, and still make that judgment call without me. It just takes compute.
Okay.
Hope that answers the question.
Yeah, no, that does, definitely. Where do we as testers get started with AI?
So I don't get any money from it. I'd recommend people sign up to aitesting.org, because that's where we're kind of disseminating a lot of this information. There is a post I put on LinkedIn called, it's like links for the AI curious.
Okay.
And it's got a lot of pointers to classes, to material, to other examples of AI applied to software testing. And most importantly, if there's one thing, this is how I did it. There's probably more efficient ways, but I sat back and just watched Andrew Ng, his last name is Inge, on YouTube, the Stanford series. It's like 6 or 7 years old. And I just kicked back and watched. I didn't do the homework. I just followed the example. He's super crisp in describing how things work. So he's brilliant at that. Like, it just makes you feel like you're smart listening to him, because he takes you on this journey and makes everything seem simple. But you don't have to do the homework, don't do the math. Just kick back, in a recliner and kick YouTube up off on your big screen and just watch those. It's only like 14, 15 hours worth of it, and you'll come out like a mini machine learning genius.
Okay.
You know 80% of it.
Yeah. That's great, yeah. At what stage in the learning process do we decide that AI has learned and is good enough?
Good enough. That's an interesting question. Well, one is we can mathematically tell. If you look at those charts and graphs and stuff I showed, you can actually measure how good they are. And also back to trustworthiness, and also even just recognizing the shopping cart as a shopping cart. The way we tell it's, I guess, good enough. I don't really never know what good enough is. I don't mean to be too philosophical, but we know that if we compare the accuracy of the bots that we trained against any individual human in the crowd that voted on what the answer was, the bots by definition beat any individual human. So I would say good enough is pretty good for production kind of deployment of these systems. If it's smarter than any individual tester, probably smarter than tester that you were able to hire for your team, that's when it's probably good enough to be deployed.
Okay, yeah. Okay, so it's a joint question on how do we use your tool, and so the same person says, so we don't need to pay for the test you will run on our app, or how do you set up your license model?
Oh yeah, I've been pretty quiet about that.
Okay.
I was going to sell to I'll overshare. I just haven't talked about it a lot. Okay. I try not to be super commercial, frankly. Because I'm focused on my task is to automate the world's apps, and I have this. My thesis and the company's thesis is if we can test every app on the planet, we'll probably do okay. Do you know what I mean? Like our model is not to go to individual app team by app team and sell them on our product and ram it down their throat and deal with long POC cycles and all this kind of stuff. My goal is actually just to automate the world's apps, and so that's why we seem like a little different kind of company. It's a very different objective than most. So the way our licensing model is basically, you can imagine there's a lot of places in the world that have to deal with, I have to be a little careful because of some NDAs, but there's places in the world that have lots of apps, right? Or they care about testing a lot of it. By a lot, I mean hundreds and thousands of apps at a time. So that's where our technology is most applicable to, not to an individual app team today. That's where we kind of flex our muscle and kind of our unique unfair advantage. So we're working with, right now we're focused on those types of companies. So if you've got 100 or more apps that you need to deal with, it's probably worth reaching out directly and talking with me. If you have if you're only dealing with 1 or 2 applications, and specifically licensing at that is just kind of classic enterprise licensing. It's enterprise sales, right? You get a license pretty much for your company to run it at whim, right, in your own data center. But the individual app teams, we have individual app teams that and you recognize that are prominent, paying us today, but really our focus is on scenarios where there's at least 100 or more apps that need to be tested at a time. And then lastly, our plan is, and this could change because we're a startup, but my goal is to have all these tests written for all the apps on the planet, at least the top apps, and share those. And so people can see test results in production and without talking to me, run your credit card and have the app, have the system and service run those exact same test cases in pre-production. And then if you want to pay a little bit more, you get access to that custom test creator that I showed you on the web.
Okay.
That's the basic model.
Okay. How do you see AI impacting developments in the healthcare market in terms of both the products delivered and the testing completed?
Actually, I don't care about healthcare.
Okay.
No, actually, quick. I'm kidding. I want to add one more thing to the thing I said last.
Yeah.
If you think about it, I've just been heavily influenced by like kind of Microsoft and Google's models, where Microsoft basically built one CD that worked for everybody, right? One version of the operating system and then shipped it to everybody. And then at Google, if you think about it, Google just went ahead and crawled the entire internet without asking anybody's permission, indexed it, made some interesting, useful analytics on that data, and then like good luck asking for help. Like you get what they deliver. Do you know what I mean? So it's just kind of a more, how do you scale? Like if I have to go individually app team by app team, it will take decades. There's a lot of teams building websites and mobile apps. So I'm trying to get a go-to-market approach, a little maybe full hubris and a little too ambitious, but idea is just to test everything and then let everybody come in kind of like to google.com and get their test results there.
Okay.
That's the fullness answer. As for healthcare, what was actually I kind of really don't care about healthcare.
Okay, I'll move on. There's some, it was just, how does it affect healthcare? Would it affect, hold on, I find it again. In healthcare market in terms of both the products delivered and the testing completed?
I would say just like any other product, frankly.
Exactly,
And I would also add that a lot of medical products, like medical and legal professions, are being devoured by AI today, right? Because like they can analyze a CAT scan more accurately. Just look it up. Don't believe me. They can analyze a CAT scan better than the average radiologist, right? And machines can process more legal historical data and even judges individual rulings than an individual lawyer can. So, and you think about it, these are people with like PhDs and stuff like that.
Yeah, absolutely.
So it's eating that field. So we as testers have to now test systems that are smarter than people with doctorates. Like it's an interesting situation. But,
absolutely.
But again, it's all just testing AI systems.
Yeah, and like this is coming on to the next question here is, should I give up computers and programming and become a hairdresser instead? Will humans ever be out of the loop? Can we trust this AI testing? I need recommended reading.
Yeah, I think a hairdresser is a horrible profession to go into, and the reason is people are going to be living longer, and people tend to go bald. Yeah. So that's a dying market. And also as we connect up with neural links directly to machines, you usually need to shave the hair to like add the implant. So I think basically everyone will just be using Nair on their head. Yeah. Eventually. I wouldn't recommend hairstyling.
Exactly. No.
But I do think what testers should do is, I wrote a little article on a couple of days ago about how to kind of convert from being a test engineer to a machine learning engineer.
Okay.
And you can buy the key thing that's magic. The magical career advice I can give in this transition is that you don't be intimidated by programming and don't be intimidated by math. You can go directly, instead of a hairdressing, you can go directly to training AI. Like you can make that leap today directly to training AI. Just go play with Google's AutoML Vision stuff. Just type Google AutoML Vision, and you can literally open a web page and drag an image into it, and it will classify that image.
Okay.
So technology is getting faster than anyone real. It's getting more capable and far more easier to use and more abstracted from the math and the implementation every month. So I would make that leap. You have to take a little bit of a brave leap, but you can skip your PhD in computer science and go directly to some basic machine learning today.
Okay. How do I incorporate AI in new development in a Scrum team?
In a Scrum team? That word is very ambiguous, like Scrum, Agile, all that kind of stuff. But I would say that the most important thing is that in Scrum and particularly kind of Agile teams, there's really there's not a tester, or it's just one kind of story or whatever, right? It's an afterthought. And when you do these sprints, usually associated with kind of sprinting, you never have time to sit back and really invest in test automation infrastructure and really deep test plannings and strategies. So I think that's what's hurting quality on these Scrum, Agile, and all these kind of teams. But what the beautiful thing about AI is going to do is that if you imagine that there's just a corpus, an open source corpus of 10,000 test cases that will run on your application, and you just have to run a credit card. So we've really designed for this type of team, by the way, which is people that don't have testers, don't have time to test, or don't want to do the boring, busy work. You just run your credit card, and the AI can come in and look at your test and perform a fair amount of intelligent testing without talking to a human.
Okay.
You're just running a credit card and you get the data in minutes. So that's where I think it fits into the Scrum daily stand-up kind of stuff, is that every morning you have, on every single build, the AI has already tested and analyzed your app. You don't have to write that test code.
Okay. Have you ever done an A/B test comparing a human versus an AI testing the same app?
Yeah, we've done two A/Bs actually.
Okay.
Well, one was, I talked about earlier, it's kind of an A/B test where after we train the bots, we can compare the simple human judgments of like trustworthiness, or is this a shopping cart, that kind of stuff with a human. And the machines fare better, right? Because they have the collective intelligence. The secondly, though, is the A/B flight was, we did some internal head-to-head comparisons. We basically had people fire up Appium, I mean to these parameters, but Appium and Selenium, and try to write 10 test cases they hadn't seen before, right? And just sat down and try to write those damn things, and write it with our tool, Test AI, and then write the same things with Appium or Selenium. And again, these were if you're writing 100 test cases, these would all be in the top 100, but they're not super edge cases. But basically, it's 100x faster to write a test case with the AI powered framework, and crazily, it's actually negative. So there's two other things. So one is that the weird thing is that now some of the test cases have already been written for an app. So like you don't have to write anything. You just say, here's the app and run, and it will run the test cases. So you don't even have to write them anymore. That's a pretty fundamental shift. And then secondly is the in terms of maintenance. So we've gone back and done tests where we've written Selenium and Appium tests, like very small set of basic tests on a version of an application from a year ago, and then we ran the same code against a version of that application from today, the latest version, and to see if those test cases break, right? Because the app has changed, selectors have changed, and stuff like that. And we've compared that with the AI version, and frankly, in our experiments, we haven't seen the AI version break at all, except when they totally redesigned their app. I mean, like completely changed the flows, like it almost rebooted or pivoted as a company. But for the most part, the AI just keeps chugging where the old stuff would break. So that was kind of an A/B comparison of traditional test automation versus the AI powered stuff.
Okay. There's a couple of questions kind of along the same lines as this, so I'll just read out this one here. If AI collects data from thousands of websites and or apps and then enforces your own website apps to look similar, doesn't it kill unique personality of the website or app and their diversity?
I'll answer that with a picture. No.
Do you want to?
Well, I already did it. Oh, am I broadcasting?
No, I can put it back if you like.
Okay, yeah, just broadcast real quick. Yeah,
1 second.
Yeah, so I can talk over it. So this basically we have this single test case, right? That the bots, it's a high-level description of test case like we're talking about, but it's running against a wide variety of implementations of apps on the right-hand side. Like DuckDuckGo's flow is very different than Bing's, is different than Yahoo. Yahoo has only 2 steps to execute a search test, right? Google takes 3. Bing, you've got to like accept every stinking, like it wants to get access to all of your data before it lets you do a search. And DuckDuckGo is similarly a little obtuse or with some splash screens, introductory kind of screens. So no, the logic, what's beautiful is that with the AI, you give it the intent. So what we call the AITs, is the abstract intent test. You give it the intent of the test case, but you don't tell the AI how to do it. So it doesn't make every app conform to in terms of implementation. It does let you verify that the intent of the user for a web search app is to search the web. And it makes sure that that capability is possible in the application. So it almost quite does the reverse. People won't grok it until you've seen it or you've written a few test cases. Then you're like, oh, like actually the least descriptive you are about the test case, the far better it is for reuse and easier for the AI to execute. So no, it doesn't inform any or force any conformity in apps. But I think it's a smart question in that the reality is if you look at all applications, look at just the set of applications for web search, they're all kind of similar, right? They're kind of solving a similar user problem or intent, and they kind of all look the same. They all have a search box, they all have test results in the list, and with little links in them. And so that conformity actually happens not because of the testing infrastructure, or would in the future. It's because these apps actually want to be more conforming, because when I download the Yahoo app, or say the Bing app, right, and try it out, I want to be able to use, my goal is not to use the Bing app, my goal is to perform a web search. And so the more Google-like, or the more common those experiences are, the more usable apps are generally, because users don't have to relearn a different flow or app design. I think that'll happen just because of usability, but the test cases won't. This kind of way to write test cases with AI actually has the opposite effect. It enables many different ways to construct an application.
Okay. Thank you for that answer. Okay, so I'm just going to ask the last question. There's so many more questions here as well, Jason. I'm going to send them to you. You might enjoy even just looking at them. So I'll send you on all the questions after this. But so how does AI understand business flow?
Similar to what, actually, to answer regarding the questions, yeah, if you can send me the questions, yeah. I'll actually take a stab at I'm pretty busy. Maybe like in a couple days, I'll respond to all of them and put them on. I'll post on LinkedIn. Probably.
Yeah, perfect. Yeah, that's great. That would be amazing, actually. Someone found your LinkedIn here, the article that you were talking about on LinkedIn as well. So that's up there as well. So there's definitely loads of information that I can share on this landing page anyways, so you can head back over there, and the recording obviously will be available as well. But I will send these questions on to you, Jason. Yes.
Great. And then sorry, the question was,
how does business flow? Yeah, how does AI affect business flow?
Yeah, so if you think about AI in terms of, AI and business flow in general, the products can use AI to do that. But from a testing context, if you look at it, this is actually, again, this is what I think is just beautiful about the AI approach is you're not focused on the implementation of it, you're focused on the business rules, right? Like a business rule for a web search app is being able to input a search query and getting these search results back. And if you look at this, if you kind of blur your eyes, it looks a little like Gherkin-esque, right? Or cucumber, but Gherkin-esque type of way to write test cases. And that's exactly how a lot of people formalize their business rules, right? And their business logic. And when they specify an application, right? Without specifying the implementation, but specifying what are the business rules and what's the business purpose of this application? What is it supposed to be able to do for the user, or how is it supposed to behave? You similarly write this in this very high level language, and we've basically tried to emulate very similarly the same syntax of those business rules like languages. So the test cases are very similar to the way the business rules are defined. So there's very little translation to test cases and ultimate execution. The ultimate dream would be that if we could actually just compile, it depends on how people write their Gherkin, but you can almost do a direct translation between Gherkin and this AIT format. And then that is executable. So really AI is bringing us where, you could write the business logic, and as soon as you write the business logic or change it, you can have test cases that are able to execute that, verify that business logic in the application without going through a human, right? Okay. So that'd pretty much be the ultimate goal. And I think we're getting a lot closer with AI because most of your focus is on just the expected business logic and business rules of the application and not the implementation of it.
Okay. Thanks so much for your time today, Jason. I really appreciate it. I hope you can get back to bed. But no, but we'll be in touch. I will send you all these questions, and folks, the recording of this webinar will be available 1 hour from this time. Please do look at your follow-up email as well. You can get the link there, and there's also an ebook on there about JavaScript. Thank you again, Jason, for your time. Really do appreciate it, and thank you on such a great webinar.
Cool, thanks, Cleo. And I wish everybody goes to STAR, your STAR without me. I wish I could be there, but I'm not cool enough. I don't have enough money for flights.
Okay. So. Thank you, Jason. Speak soon.
Thanks, Bruno.
Bye.
All right, see ya. Cheers.
Bye.